T12.12. A study conducted in Charlotte, North Carolina tested the effectiveness of 3 police responses to spouse abuse. Number 1, advise and possibly separate the couple. Number 2, issue a citation to the offender. And number 3, arrest the offender. Police officers were trained to recognize eligible cases. When presented with an eligible case, a police officer called the dispatcher, who would randomly assign one of the 3 available treatments to be administered. There were a total of 650 cases in the study. Each case was classified according to whether the abuser was arrested within 6 months of the original incident. Okay, so we've got the police response as advise, citation, or arrest, and then the other variable is whether the offender was arrested within 6 months. All right, so part A, explain the purpose of random assignment in the design of this study. Okay, so the purpose of random assignment is usually so that we can make cause and effect conclusions. So for this particular study, right, we want to be able to say that random assignment will allow the police department to conclude whether one type of response is causing a change in the arrest rates of the offenders. Police department to conclude whether or not the response is causing a change in subsequent arrest. Now, in general, random sampling, the purpose of that is so we can generalize to a population, but random assignment is so that we can make cause and effect conclusions. All right, part B. State an appropriate pair of hypotheses for performing a chi-square test in the study. All right, so let's figure out what type of chi-square test we would do. All right, so I'm thinking that this is probably going to be a chi-square test for homogeneity. Now, even though we don't have any sampling going on whatsoever, we do have 3 treatment groups. So we have multiple groups here, and we're investigating the arrest rate of each of the 3 groups. Okay. So this is going to be a chi-square test for homogeneity. And so the null hypothesis is that there's no difference in the distribution of subsequent arrest for the 3 treatment groups. And the alternative is that there is a difference in the distribution of subsequent arrests for the 3 treatment groups. All right, part C. Assume that all the conditions for performing the test in part B are met. The test yields a chi-square test statistic of 5.063 and a p-value of 0.0796. Interpret the p-value. All right, so let's just start with the sentence stem for this interpretation. It goes a little like this. Assuming the null hypothesis is true, and then we would kind of write what that means in context. There is a p-value probability of getting the observed result and we would write down what that result was, or more extreme, purely by chance. So the null hypothesis is that there's no difference in the distribution of subsequent arrests for the 3 treatment groups. All right, I didn't really leave myself a whole lot of space to write that, so I'm just going to copy it and just shrink it down. That wasn't very smart. Okay. All right, so put that right there. This is part C. All right, so assuming the null is true, that there's no difference, there is a 0.0796 probability that we would get the observed result, which was that chi-square value of 5.063, or possibly more extreme, purely by chance. All right, the final part is what conclusions should we draw from the study? Now, to answer that part, I'm going to assume the significance level is 5%. Okay, so let's assume alpha is 0.05. Right. Well, in that case, the p-value, or we can say since 0.0796 is greater than 0.05, we fail to reject the null hypothesis. Okay, which then means we do not have convincing evidence for the alternative. There is not convincing evidence of a difference in the distribution of subsequent arrest for the 3 treatments.